So yes, historically, what I've used for creating serverless applications that don't have a UI is the serverless application model. So the serverless application model is really a superset of CloudFormation. And it does some of the boilerplate work of wiring up different resources like API gateway for putting a REST API in front of your Lambdas, or like the event bridge for scheduling Lambdas, stuff like that. So the other nice thing about SAM is that you get the ability to execute your code locally, and it handles the dependencies for your Lambda functions. So like it will pick up requirements.txt and pull down those resources when it builds and ship them up as you deploy your CloudFormation. So the serverless application model is nice, though it has historically only worked with the more traditional CloudFormation. The way things are going, the CDK is what is kind of the future of CloudFormation. It takes what was historically either YAML or JSON files and turns that into code, actual code. And you can use JavaScript, TypeScript, C#, Python, or Java, and you get the same functionality. They actually use a library, JavaScript library, GSII, I think I got those letters right. And what that does is they actually natively develop in TypeScript, I believe, and do a translation for the other languages. JSII is the library that does the transformation. And so the code that you're getting in Python is the same. The APIs for CDK is the same no matter what language you're in, because really there's only one source of record for the code, which is the TypeScript code. So if you do decide to switch from one programming language to another in CDK, you'll have all the same things. You'll just be using a different coding syntax, different language syntax. So with that, there are obviously the tooling that works with the historical CloudFormation won't out of the box work with this new context. CDK generates CloudFormation. It's still gonna, in the end, it's still creating CloudFormation, but it's a process to get there. So because you don't start out with the CloudFormation, the SAM needs a little bit of help to understand where the pieces are. So this integration is beta. So some of the things I'm going to show you are very hacky, but it will allow you to use SAM and CDK together now. And so what I'm going to start with is really what the examples online give you, and AWS spells all this out in their documentation, and I'll link to it all. Actually, I think that the pages I linked to in the event pointed at this as well. The first step is you synthesize your CDK into CloudFormation. So when you do the command CDK synth, what that does is it takes all your code that you have currently and turns that into CloudFormation. You can then take that CloudFormation and point SAM at it. So SAM can then leverage that CloudFormation. Now, the challenge that one of the first challenges is that the requirements.txt, those dependencies, aren't handled the same way in SAM as they are natively in CDK. What I have defaulted to is just let SAM handle it. And that's where I have a little bit of a hacky workaround. I have a helper method that after SAM has built the dependencies and built the assets, it's always put in the same place with the same naming pattern. So there's I have a helper that when CDK goes to deploy, it looks to see if that folder and picks up those assets instead of the default CDK assets. That's really the gist of what makes this all work. It does take and where it really gets a little bit awkward, we'll say, you have to clear out those SAM folders just before you do your build, because the CDK code will be called twice. The CDK code will be called when you synthesize, and again, even though the CloudFormation has been compiled, the CDK code will be called again on deployment when you push your code out, so that you can. And I have output lines. I wasn't expecting that precisely, but that is the way it works. And so I'm able to, on that deployment round, say, no, use these other assets instead of your default assets. And so I have this helper method. It's just a helper function that I pass the asset path through. So we'll take a look at that. I need to, just a moment, pull up a example, copy over an example that I missed. There we go. Okay, and so now share my screen. Okay, so this is my Lambda function in CDK. The ID of the Lambda is actually just giving it a name. Okay, and this is, so here we have the use of that helper. Where did I? So instead of passing this asset path here, I pass it through my helper. and that helper, and I will post this code out as well. I'll put a link out to this. In the SAM build folder, I haven't actually done a SAM build in this project yet, but doing a SAM build will create a .aws SAM folder here. And in there will be a build folder. And in that, each Lambda that is built will get a folder that starts with the name, the ID of your Lambda. And so that ID will have all of the hyphens removed. And so it'll be all one long string if you use hyphens. And so I just look for a path that starts with, because then it'll have a series of random characters at the end to make sure that the path that it creates within its build folder is unique. But so I just look for a path that starts with that. It will always be the latest. Even if I don't delete the folders, it will always be the latest. There will only be one folder in there for SAM, and that will be the one that you'll want to use. So the trick here is that the reason why I delete is what I look in here to see if the this build path exists. If it exists, then I use it. Now, as you're going through and making changes in the code so here in CDK, this is the entry point for CDK. This app.py in the root of the project. So in here, you import all of your stack. Each stack, the encapsulation of different resources within AWS. When you're deploying, they deploy into stacks. So a stack can have a list of resources in it. So the way that translates into CDK is a class. A class you can create a class that is a stack. And so this is my sample stack, and in it is my function. So here, the CDK in CDK, it creates the app. You have your stack, and the app executes a synth, synthesizing it. To execute this on the terminal, you'd run CDK synth to actually execute it, and then CDK deploy to push it out and actually apply those infrastructure pieces. So when it runs, it obviously instantiates that class, and in the class here, in the initializer, you have all your code, and it goes through and analyzes the code structure. It does execute the code, but it also analyzes the structure of it all and understands that if you are running, like, you can take this out. As a side note, you could take this out and put it into a function or a method within the class and call that repeatedly, and it would repeatedly create instances. So if you wanted to template out a set of resources and just pass a couple of arguments in there to differentiate the instantiation of each of those resources, you can just do that. That is a change in how a lot of people thought about CloudFormation or the even Terraform, because you don't have that same ability when you're talking about Terraform or CloudFormation. It's creating those programmatic reusable pieces was much harder before CDK. So it comes through here and creates the method and or creates the Lambda, and you tell it here from asset what the path is to your Lambda code. The Lambda code here is in this folder where I have it called function. So in here I have a requirements.txt, the dunder init, and pi and app pi. So this is just a simple function, but this is separate. This is not part of the CDK app execution. This is just content for the Lambda. So in the sample stack, when I go through, the first thing I do is I delete that .sam build content folder. And so when it comes through, in here, I look for the folder. If it doesn't exist, I use the path. I use the path that is, so here, if this exists, then I use the SAM build path. If this doesn't exist, then I'm just using the path that I pass in. And so when you first go through, when you do your synth, you want it to use this folder for your asset so that it copies the very current version of code into the SAM output folder. And then when it comes through and does the deploy, when it comes through this piece, it's going to go into here. Now the .sam AWS SAM folder will exist. It comes through here and says, oh, here it is. I found the path. Use that path for the deployment. Now, this might seem like a lot for kind of getting around something, but the alternative is that you can tell CDK to pull in resources, but SAM doesn't acknowledge. You know what? As I'm talking, I wonder if the synth, I bet the synth would take care of the resource handling. So I didn't actually try that. So I bet let's try that real quick. I am going to, I may have just had something occur to me that spoiled my talk. Let me switch over to this. So AWS CDK 2, and you want to make sure you're using CDK 2. And Lambda assets. So I am pretty sure that I saw, oh, this isn't what I want. So this is the primary API reference for CDK, and you can see up here, it has links to all the different languages that you might want to, or that you could develop. So now we're in the Python documentation. And some of these things that you'll see in here, like the Lambda Python, these are experimental. So You can use them, but being experimental, you can't trust that the APIs won't change as they get developed over time. So the other, if it's not labeled as experimental, you can be confident that it'll be stable and the function calls won't change or the argument lists won't change. So here, asset code, local folder. I am pretty sure that I saw in here that Lambda function. Attributes. Sworn. Target. So as you can see here in the documentation, they often give you examples of how to do a basic initiation. There is code completion within within Visual Studio Code. No. Yeah, they often a lot of the documentation points to layers as a way to handle dependencies, but I do not recommend working with layers. If you have multiple different lambdas, the tendency is to want to use layers like a library, like a shared library. But if you have multiple lambdas working off the same layer and you want to update that layer, it really wants that layer to stay static, because that you have the CloudFormation deployment process doesn't really work for allowing the layer to be updated. But I could have sworn there was.
Are you trying to figure out right now how you can call like CDK synth and then under the covers it calls SAM build?
Not
Which
SAM, but I thought that there was asset handling of like dependency libraries. I thought I saw that at one point. And what didn't occur to me before was if that is the case, the CDK out folder that SAM would point at, and that would make it so SAM, you wouldn't need to do a SAM build. What I typically do is a SAM build against the CDK out folder, which will have everything that was in the that function folder, including that requirements.txt, and the requirements.txt would then indicate to SAM, go out, get the dependencies, get those third-party libraries that you are dependent upon, and then it puts that into the AWS SAM folder that I referenced during the deployment. So code. And maybe I was imagining things. So maybe I was wrong. Okay. Bundling. Bundling assets. Executing command. Bundling path. No. I think this is what I saw. Bundling functions. Environment, local volumes. No, I think this is different. I think this is what I saw and thought that it might be dependency handling. Yeah. Okay. All right. Cool. So what I have to say is still valuable.
Are you using a Docker images output or are you using a zip file today?
No, zip file.
Okay.
Dependency source target. No, this is for different construct dependencies. Okay. So back to the code. So yeah, the dependency handling is huge because it's just one more thing you don't have to worry about. You don't have to think about as part of the process. And so you didn't use SAM, you would have to go and make sure that whatever third-party libraries are included within your function. So, and when you have a lot of applications or a lot of functions, and having to copy in those libraries, that's why the requirements.txt exists. So you don't have to do that. So here, all right. So here now I will do a CDK. So I actually already have a CDK syn. I just ran a CDK syn. As you can, this is the output from the CDK syn. If you have more than one stack, instead of outputting the stack syntax like this, it'll say it built in a list of the stack names that it created, which is handy because then in the deployment you can say deploy just a particular stack, and you can copy and paste the stack name, especially if you sometimes I'll have a dynamic stack name in the code for different environments, or if I put a prefix on it for a particular context, that list of stack names can be helpful. So now a SAM build of this template you see here, -t /CDK out sample template. Now, right at the moment, this doesn't actually buy me anything because I don't have anything in requirements.txt, but say, let's see here. Take a look at let's do that. So I just added request. Is it request or requests?
It's request. It ends in S.
Yeah,
That's nice. All right.
right.
So this will take longer than you would like often, but is now updating the assets, the templates in CDK out folder. Oh, and oh, I bet it is Lambda name. And function ID function name. Okay. Now we run the synth again. All right, yeah, and this, so this is the output. Oh, I have a print statement at in my helper function to say what path is being used. Just wanted to double check something here. Yeah. All right. So now if we look here, so every time you run the CDK out, it creates a new asset folder. And so you can look in your template here to say, so this Lambda function, S3 key, you can see that this starts with 01B. So 01B is the asset, is the current asset. And you can see in here, you have your requirements, AppPy, and Dunder and it. So now down here and up here, you have that. This is from the prior build. You can see I have AWS SAM in a build folder. Right at the moment, there's nothing in it. So now we try that again. Build failed. Yes. I believe. All right, I have 8.
Can you explain why are you running SAM build from the CDK out directory? Like, I'm just trying to understand your workflow.
Because SAM can only work with the compiled template, CloudFormation template. And so the CDK out folder is the output of your CDK application. That is the CloudFormation template that your CDK application creates. And that is what gets uploaded into AWS and executed as your CDK stack.
Okay, so CDK out is the synthesized thing that's pointing at the output of SAM. Yes?
No, SAM is using the CDK output.
Oh, it's reverse. SAM is using the CDK output.
Yes.
So so
I the CDK runs twice. It runs for the synthesize and then it runs for the deployment. When you run the deployment piece, it says, the SAM output exists. Use the Lambda function contents asset out of SAM instead of what I have in the CDK out.
Oh, okay. It's somewhat confusing, but okay.
It is. I don't deny it. All right, so now we have this. And this should be, oh, you know what? So when you tell SAM to build, you can tell it to build in a container, and then it doesn't matter what your local machine has. It will use the container and build within that context, and loading the proper Python version within the container context. So now we have in this build folder, my function, bunch of random things, and all of the dependencies based on the requirements.txt. So now when I do a CDK deploy, I'm going to use my personal profile. The profile stuff is for authentication into AWS. I work on a lot of different accounts, so I have many different profiles on my machine. What you will probably do just playing around by yourself is putting your credential information just into the default, and then you don't have to specify profile. Default is obviously default when you don't specify profile. So now, if everything works correctly, that output that you see, that you saw before, that was pointed at sample slash function, will now instead say AWS SAM build my function 3BAA. Nobody ever said CDK was the speediest thing on earth. See, now it's pulling from that AWS SAM build my function instead of sample function. And I do agree that this is confusing, hacky, and I can't wait to see what they come up with in their official release of SAM support for CDK.
Have you heard about SAM beta CDK?
I was using it, and they actually seem to have stopped promoting it in favor of just pointing SAM at the CDK output.
Okay.
It's no longer to be found on the website.
Yeah, I saw it in the blog because this feels wonky to me.
It is
for how they are interacting. You would it honestly makes me think that the SAM should instead be able to, instead of pushing, pointing at a template when you run, SAM deploy or SAM build, whatever, you should be able to give it an option that says point at like a CDK folder that then goes in, instead of you having to feed it a CloudFormation file, you can feed it a CDK folder, which then SAM build would automatically call CDK synth to generate the template that then SAM build would use, if that makes sense.
Yeah, no, that does make sense. And I don't know what the development workflows are within the SAM team, but yeah, no, it makes sense. And the thing that I miss out of the SAM beta CDK is that you don't get the SAM bootstrapping of a project.
Right.
The SAM beta CDK created, like, you still, when you do a CDK init, you get basically this project here was created with a CDK init. This is what you get when you start out with a CDK project. You don't get an empty repo, you get that initial stack where you can start adding resources. But with the SAM beta CDK, it actually, like in SAM, you're able to start with a more realistic, we'll say, bootstrapped initial starting point. Like, it will have the API gateway and a Lambda, the basic setup there. Whereas here, you really just get an empty stack with a commented SQSQ to kind of show you what the pattern looks like. But yeah, no, I agree. There is a lot to be wanting in the SAM CDK integration right at the moment.
Okay, so is the sell for this then that, hey, instead of using SAM with a CloudFormation template, what your goal of what you're actually trying to achieve here is, you basically want to use the output of CDK as a feed in to SAM. So basically the CDK output would go into SAM build, and then SAM build then generates the final CloudFormation that then.
So the only thing I'm using SAM for is in this, what you just saw is the dependency handling.
Okay.
My goal is to do as much in CDK as possible.
Okay. That handles the CloudFormation creation, but SAM takes doesn't SAM usually, when you are doing a SAM you're not using SAM deploy
I'm
at
not
all?
using SAM deploy.
Okay. So then you're having to go in via CDK and yank the output zip, and then how are
It's
you?
not a zip. It's not a zip. It's like this is a folder.
Sure. Yes.
But
So
yes,
you're yanking
assets.
the folder, and then you're uploading it to S3, or CDK doing that for you?
The CDK is doing that. I'm just redirecting CDK. Use this folder instead of that.
I see. So in theory, you would be looking for, as a future enhancement, you almost want a CDK build that runs the SAM build underneath it for you. So that way you can then run a CDK
or
deploy.
like you were saying, the other way around, doing
one way or the other.
Yeah.
Yeah.
But what this also allows for is you can still now use SAM for the local invoke and the SAM build for the dependency management.
Sure.
And
interesting stuff.
And yeah, those two things are what make really the SAM worthwhile. The other thing, the third part that makes SAM worthwhile, CDK already does. There's those higher level abstractions that you don't have to know all of the little interconnecting pieces of the low level CDK resources, or the low level CloudFormation resources. You can just say, create a API gateway. Oh, and here's the Lambda that I want at this endpoint.
At that entry point, yeah.
Yeah.
Because then you have to, I mean, there's pros and cons to it because when I originally was using SAM, it's been a little while, but the problem was they were automatically creating stages in the API
Oh yeah,
gateway.
I ignore stages.
Okay, yeah, like
They,
it's one of those things of
because
it was another exposure is what my security team saw it as. So I was like, well, great. So then I had to end up coding 90% of it anyway.
the stages get obfuscated with whatever URLs you have pointed at it,
Right,
pointed at API gateway. And
right.
I don't, yeah, it's just it's just another name. It's just a name.
Okay. So the only other thing that I would definitely potentially think about in this workflow, have you ever used SST? Have you ever heard of it?
No.
SST, it's serverless stack. What is the actual name? Serverless stack framework, SST. What it has is something that I'm seeing other companies start to migrate to instead of using SAM local, which is the basic premise around SAM local and a lot of other frameworks are that you basically have to mock everything, every other AWS service like DynamoDB and everything like that. And if you're in a true serverless framework, or if you're using serverless in general, and you're also using serverless backends and things like that, the theory that they're operating under is it's cheaper to stand up an entire copy of your app using serverless and then proxy it to your Lambda function code running locally. They use WebSockets. It's actually kind of interesting. It's like a it enables hot reloading. So you can change your local Python code while API gateway is pointing at your basically an endpoint that's running on your laptop. And so you can change your code, you can run an API gateway, or you can feed it an event, and it'll actually call your code locally because it's using WebSockets to come back in to your local dev environment. It's it's very interesting stuff because one of the things I've been seeing is more and more companies are saying every dev deploy an entire application stack that you can test yourself against real AWS because the mocks are getting so complicated now.
Well, see, I have never gotten into mocks. They don't make sense. They don't work. Because so what I've always done is pretty much that. It's so when I'm testing my Lambda, if my Lambda needs to connect to a DynamoDB, I have a DynamoDB that I'm connecting to, whether it's something that I just throw up randomly in the console, or it's something that I actually spun up through the SAM stack. It it makes so much more sense. You pass it your credentials and it connects to the actual AWS resources. But having that kind of that serverless context, that API gateway that points back to your machine, that's real intriguing.
So I just sent a link to it in the chat.
Okay.
But I've been reading about how are more serverless type people doing it. And it's actually very, very interesting stuff from a local developer. So it's all about local developer, like making a change, testing something, making a change, testing something. And I've been starting to get onto the bandwagon that while you can unit test and do all these other things and they're great, assuming that you're mocking the proper thing coming back from DynamoDB, but at some point you have to get to integration testing, and you really can't beat just spinning up all the serverless resources that basically cost almost zero money. And then if you think about it, you have a guaranteed 15 minutes to do a debugging window because it deploys a debug stack that then proxies it back. And Lambda functions can run for 15 minutes. That means you can actually put breakpoints in your code and walk through it. I sent a link, just something to consider to add into your tool set for local Lambda development.
Yeah, for sure. That's super cool. It's kind of like the containerized development in Visual Studio, in Visual Studio Code.
Yeah, same idea.
Yeah, that's awesome. So yeah, now this has been deployed with the dependency libraries, out into AWS. I can show you that if I remember my own login. Just a moment. Okay, we will go to console. Let's see here. Leave this. Okay. Oh, actually, there it is. Okay. It's entirely, and so here is that my function Lambda that I just created. And hey, it does. So sometimes it's very easy to create a Lambda that does not, that's too big to display here, and you'll just get a message saying it's too big. You gotta edit it somewhere else. But luckily, it's small enough. You can see the list of dependencies and the function I uploaded. This won't be very exciting, but you can execute it. It outputs. Let's see if I can. I just want simple. So here, I'll do the full. So function. Here and I am not actually sharing my screen. I'm sharing the window. I will do. All right, so I am just adding this into, so I'm now importing requests and making a request, printing the results. The result will be shown in the logs. So here in this function logs output, you will get logs so that as your functions execute, you see all of the print statements, all of the, whether basically anything that would normally go to standard out. Within CloudWatch, you can go back and review the view here in the Lambda console is limited. You do have some context, but the interface you have with CloudWatch is much easier to manage. So in here, you can see I had that output, that first line output that says print the event. that so this is that printing of the event, and that when I was doing the test, when I ran the test, this is the, like, you can construct the event that may be passed to it, whether that event is an API gateway call or the event bridge scheduled call. When you can create a, so you can create a new, and they have templates for all the different types of events that might get passed to it. So let's look at API gateways, probably at the top. And so now you can see here, it's a mocked out version of the API gateway call. And also you can do this same type of thing locally. So you can create a JSON file locally and pass that into your SAM local execute to really test and really exercise your code locally. And then SAM can so SAM can pass this. You can pass environment variables into the SAM local execute command, so you can really mimic the environment that is out in the deployed Lambda context. So that environment variables are really how, like, if you have a standard function and you want to stamp it out into different instances and pass it in parameters, it's environment variables. You're passing in different environment variables to determine what that context is. A lot of times I use that for deploying to dev, staging, and production. I pass in which environment am I in, and then I use that in the path to my parameters. But the parameter store is where the different configurations are stored, or secrets manager for database credentials, and each of those has a name, and you just bake the environment name into the secrets manager name or the parameter store name, and then you can construct that name based on which environment you're the value of the environment variable. So that you can see here, output that dummy event as that first line. Back here we have our requests, and so I'm adding in, making a simple request via the library, the requests library. So now here I will create the cloud formation and that asset. Honestly, I probably could have just run the SAM build because the template didn't change, that just the code changed. And so because just this function changed, I probably could have just run that SAM build. I would have to, generally I work with shell scripts that will do the series of commands that I want to do before each operation. So for my context where I want to now build, so if I do a SAM build right at the moment, or oh, actually it was a synth. So the synth, actually this is a good example. So that synth picked up the SAM build. So instead of the changes that I just made out here, we can see that the S3 key is now A to A. So in here, A to A, if I look at the app, it doesn't have my request. It doesn't have the import. It doesn't have the GitHub request because that SAM build folder exists. It's ignoring what's down here. So that's why I say you got to clear this out. And like I said, I generally have a shell script that says, okay, I'm about to do a synth, delete whatever AWS SAM folders I have out there in the build folder, or I think I just delete the build folder. I'll do that. And then I run a CDK synth. And I'll create a fourth asset folder. Good. Now it's using the new updated code. And we want 4CF. We now have our updated code. And we can do SAM build. And it'll take that updated code and build. It put a build folder back. And now we have our function with all the dependencies and the updated code. And we can do a CDK deploy. One of the conceptual hurdles of transitioning from CloudFormation into CDK is that the parameters that you pass into the templates, you don't use the CloudFormation parameters anymore. It's still a concept that exists, but all of the CloudFormation template pieces are constructed. So CloudFormation or CDK is going to generate even the parameters that go into the outputted CloudFormation template. So that, and when generally with the CloudFormation, the parameters into the CloudFormation dictate the flow, dictate the structure of the resources that are built from that CloudFormation template. Well, because the CloudFormation template parameters are part of what is getting generated, it's too late. And so the way that you provide parameters in a CDK context is environment variables within at the time of the synth and at the time of the deployment. So you set environment variables, and that's another thing that I put into my shell scripts. So your shell scripts will set your base context, whether that be other resources that are outside of your CDK that you want to include. So like a database reference or a network reference or a load balancer reference that just happens to be outside of your CDK project. you have to do that via an environment variable. And so I throw that into a shell script and just include that every time that I do a synth or a deploy. Oh, deployed. Here, refresh this. Code. See, now we have the result. We'll see if this blows up or not. Yay, response 200. So you can see now that I have included that requests library. The dependency was resolved with using SAM, and everything else was done via CDK. So that was really, I've been using CDK pretty extensively, pretty exclusively since I started, but this is really what has allowed me to use CDK, because generally what I'm doing is serverless deployments. One of the next talks I'll give, I don't know how soon, but I'll give a talk on Amplify. Amplify is basically a framework of libraries. We generally are using React, though sometimes we've been using Vue as well. It ties the AWS resources like Cognito and Lambda's API gateway. It ties it into a consistent architecture and helps kind of boilerplate, again, like SAM boilerplate some of the wiring up of resources. Amplify just takes it to the next level and helps you set up Cognito for user authentication and user management through your JavaScript and right through to the Lambda. So you have your identification of who's logged in, and it generally just a couple of lines in the command line, though it's still it's going through some growing pains, and so there are some times where we've had to help it along a little bit, but it has been immensely helpful and has saved us a ton of time. So Amplify is definitely something that I will cover, and I'll see if I can come up with a couple examples of what to look out for in it, because like any framework, there is going to be some rough edges. So yeah, does anybody have any questions? I know that this is a lot of concepts that you might not be too acquainted with, but it's some pretty cool stuff. I love serverless development. It really kind of frees you to focus on the task at hand rather than the infrastructure. It's different infrastructure, but it's not having to worry about scaling, basically.
Where do you decide what gets included? So the $100 question is, how when you're working on any kind of complex application where there's multiple teams involved, how do you decide what goes in your CloudFormation stack versus someone else's? Like, have you had to deal with any of that, or is it mostly you own the code soup to nuts in a single repository, like maybe multiple Lambda functions and how they integrate via queues or whatever? Like, can you describe any kind of how you deal with that kind of complexity?
So the closest that I've gotten to that is I have a shared stack. And so resources that are common, like the stores, whether it be S3 or Dynamo, get their own stack, and then separate stacks for the deployment pipeline, for Fargate, for Lambdas. I'll often, in larger projects, I'll often have a stack per Lambda, or not really per Lambda, it's per kind of domain. And so oftentimes you'll have like, I had this workflow application that had an S3 input, and it managed a queue to try to get work done in a certain amount of time. So there was a stack that was the processing off of the S3 and into the queue, and then there was another stack that was the a Fargate context with it that was pulling off of the queue for a series of different containers. So the Fargate instance was its own stack, the pipeline was its own stack, and so then obviously using import and export parameters to coordinate amongst the different stacks. So I was able to working on that, but that's about as close as I have come in that regard. I have not had to deal with the kind of enterprise multiple teams working on multiple stacks that all kind of interdepend on each other. But what I have done is if there are resources that are to be shared, they should probably be separated out and not in those more domain specific stacks.
Yeah, one of the things that we've tried with mixed success, depending on the use case, is we try to figure out what is the integration point between two application domains.
Yep.
And then we usually stick a queue in between.
Yep.
Of some kind. Now, if it's cross account, that adds a whole layer of complexity, but
Yep.
let's assume same account for this conversation. The way that we've handled it, so I'm not a big fan of output parameters on CloudFormation, because what happens when your stack name is uncontrolled? Because what happens if you want to do dev in an account? Well, you want the stack name
if you don't control the stack name, then that kind of goes out the window. Do you just kind of construct, do you have like naming patterns that you follow?
So no, what we ended up doing, and the CDK supports it along with obviously CloudFormation, for something that needs to be discovered between application teams, we write SSM parameters from System Manager. And then what happens is that becomes the contract between the two different teams, or the n number of teams. So the idea would be, let's say I need to pass a bulk piece of data between application team 1 and application team 2. What I would do is I would either throw in S3, Dynamo, whatever, and then I would create I would look up in my Lambda, what is the queue that's in between me and the next person? And then I would put into the queue the location of the S3 or the Dynamo, whatever. And then the schema of the message, along with wherever I place the data, is the contract. And then the next team then consumes off the queue to do the next layer of work in the data pipeline or something.
Yeah, and so you're totally separate. Your stacks are totally separate. The only thing that they really share is the messaging.
Yeah, I mean, yeah, more or less. I mean, it depends on if you're going for a microservice architecture where you're pulling off of a message bus, and you're keeping your own copy of data and all that kind of stuff. Like, can you do your two layers of the application in parallel or not? Obviously, that's a different conversation where you're using some kind of messaging bus like EventBridge or something like that. But yeah, the general gist of it is, it's either using a queue, and the theory behind it is that's better than trying to do API integration,
Yep. Yep.
unless you need to coordinate it.
Yep.
Like, part A of application B, do this, then this, then this. Unless you have to do something like that, it just logically makes sense to be async, so that way you can scale different applications at different tiers.
Yeah, that's the fundamental of computing right there.
Yeah.
No, I'm with you. Yeah, I'm often at a point where you hit your 15 minutes on Lambda, and it's like, nope, this isn't working. Okay, queue, and how could I split this up?
Yeah, I mean, usually if you get to a point where you can't do it on Lambda, it starts making Fargate look a lot better, or AWS Batch, or one of the many other services where you don't have that limitation.
Yeah, it's true. I have rarely run into a situation where I've had enough kind of single process processing, something that I couldn't split up, where I couldn't just take it and throw a bunch of items onto a queue and process them individually.
Yeah. The other thing, and we looked at it, was, I know this is well off topic now, but we looked at step functions to like put things together, and we've realized that at scale they cost a fortune.
They do. It depends. It really depends. The step functions are super useful, as long as you're not doing millions of things in an hour.
Yeah. I mean, we looked at it as, so our platform is basically we schedule phone calls to be automatically sent out, and like for healthcare, but before we do that, we ingest member data. We're ingesting millions of members of data, and each one is like a separate request, because that's how our customers talk to us. It's stupid, but whatever.
It's all good.
Well, if you can imagine the way that you ingest the data, you have to hit multiple domains to do that. So step functions would logically make sense. But then when you look at actually using it at the many millions, it starts to fall on its face.
And I actually looked at step functions for that workflow that I was just talking to you about, with the going from S3 into a queue into Fargate. But that was going through many hundreds of thousands of rows of data and splitting it up and coordinating and trying to get it. Basically, it's a fan out and back in. So, and consolidate, which step functions could do perfectly well, but like you were saying, it's not cost effective if you're looking at high volume, fine granularity. If you have a high complexity, low volume process or lower volume process, then it's totally reasonable, and there's not much that can beat it, like for being able to kind of visualize the workflow. And it's just a matter of volume, though. You have to have the right complexity of workflow and the right volume of workflow.
It makes sense. Okay.
Yeah, great presentation, Josh. Great introduction to CDK and SAM. I attended a RocPy presentation last week, and I believe they're using Lambda for like virus scanning. So do you think Lambda in general is better used for like, I guess, things that are not super time sensitive? Because I think you're also mentioning Amplify. Do they do some things to make it a little bit faster to serve sites?
No, so what Amplify does is it brings together a lot of different pieces. So it is kind of a wrapper that allows you to piece together your web GUI front end and the back end pieces of Lambda and your database and the that API layer, so that REST API layer. Really, what Lambda is a specialized container. It's a specialized Docker container. It just it runs out. It's out there. It has your piece of code that you saw here right in front of you. My Lambda handler. It is a specialized Docker container for running your Lambda handler. But it has a limitation on how long it can run. So it's simplified, but it can only run up to 15 minutes. So if whatever you're doing, you can get done within 15 minutes, then Lambda is great. Because when it's not running, you're not paying for it. You only pay when it's executing, when it's actually running code from a request, from an event.
So I made a really simple example using a Lambda function. It goes to like a Reddit, like a subreddit, and it uses like Beautiful Soup and like an RSS library to, I guess basically just get the text. And it takes about 4 seconds if I'm like starting from fresh.
Yeah.
So if I was like using that to like serve as on a website, that might be that kind of feels slow. Do you think, are there other ways to speed it up? I mean, I guess
so
it always depends.
It depends on how frequently it's requested. So, and also how much memory you give it. The more memory you give it, the more CPUs it gets, but also the more expensive the time is when it's executing. So if it's not running fast enough, it's either because it hasn't been executed in a while, and if it hasn't been executed, and I don't know what the time frame is, but once it's executed, when you request it first, it spins up that container, and so you have that little bit of lag of spinning up the container, and then from there it stays there. It stays in memory essentially. The container stays running for a certain length of time. So requests after that will be quick. But then if there's a gap in time where it's not executed, it's going to be shut down, and the next request is going to take a few seconds to come back because the container needs to spin up.
Cool. So like, I don't know, with Amplify, do you think, I guess for my example, I guess I could save that data, maybe it'd be faster than requesting it each time.
You could cache.
Yeah. But like for Amplify, could you get that time down probably to 2 seconds?
It's the same. So with Amplify, you're going to have the same problem. Amplify is really just helping you to spin up those resources. It doesn't actually speed up the resources. It speeds up your development time.
Okay, yeah, that makes sense. Yeah, thanks. Yeah, I guess maybe it'd just be faster if I cache it or save that data instead of doing it, requesting it fresh every time. Yeah, cool.
Yeah, and the other thing, like we were talking about before, is like if you have a series of websites that you want to run that on, what you could do would be to pass that series of websites to a Lambda. That Lambda could put each one of the websites into onto a queue, onto an item onto a queue, and have another Lambda that takes that off, and that Lambda would just do one website, and so it pulls it off of the queue, does the Beautiful Soup processing on that website, and but because you have it in a Lambda attached to a queue, you can tell it to have concurrent instances. So you can make the processing of your series of URLs parallel processing. And so you have multiple Lambdas all executing at the same time and process through your code even faster. But it sounds like you might be just going against one URL, but I just wanted to give you an example of the one direction you could take to leverage the power of Lambda and the scalability of it.
Interesting. Yeah, thanks. Yeah, because I guess for my case, if that was just serving like, the Reddit, that Reddit forum, I don't know, to me, it seems like, $5 light sale instance might be a better fit. You kind of,
Oh yeah, no, for a website.
Yeah.
Yeah. There you can also host a website if it's just JavaScript. If it's just HTML and JavaScript, you can host it right out of S3.
Okay, cool.
If you have when you deploy your Amplify application, the JavaScript portion of it actually gets pushed to S3. So you just have your the static website includes JavaScript and hosted out of S3. And then that connects back to Lambda functions for the backend piece. So it's really a serverless application. Like with Lightsail, you still have an EC2 instance. With Amplify in a true serverless application model, you have your website hosted out of S3. There's no servers that you have to manage there, and then when the website is loaded into the browser, the JavaScript in the browser communicates to API gateway that is the web accessible front end for Lambdas. So when you have a Lambda, that doesn't mean that it's accessible publicly. In fact, it means that it's not accessible publicly until you put something like API gateway in front of it. An API gateway is that REST API, and it's really routing. You can think of API gateway as the routing that you generally have within a web application.
Awesome. Yeah, thanks.
And you can also, by default, S3 only supports HTTP websites, but if you add CloudFront to it, CloudFront then allows you to add SSL to the page load. And then from there, then you hit API gateway or whatever you want on the back end using Cognito or whatever you want to do authentication or authorization. We're actually looking at using Okta for like
we've done that.
Yeah, for the IDP, where we basically point the API gateway at Cognito pool. The Cognito pool is then pointing at Okta. So then when a user comes in, they put in their creds or they click login, and if they're already logged into Okta, Cognito goes out, grabs it, brings it back in, and then Cognito via API gateway then says, yes, you can come in and hit whatever API you want.
We actually did a custom authorizer that skipped Cognito entirely with Okta.
Oh, really? You didn't?
Yeah.
Is that because Cognito didn't support it, or was that for another reason?
Just the client had requested just using Okta, and so we just take the Okta user ID and pass that into Cognito when the user is authorized.
So with Cognito, it skips that step where when you come in, let's say you have a front end app, and let's say you try to click a button that calls an API, right? If you have an Okta session already logged in, and you come to the app and you click the button, when API gateway hits Cognito, Cognito says, hey, is this user authenticated? And it uses the cookie that's already in the browser. And it says, oh, you're already logged in and you're authorized. Come on in the door. And then API gateway lets you through. It's kind of nifty because it doesn't, as long as you've logged into Okta and you're at the, you can see your application tiles, it works. Now, the only thing that kind of sucks about it though, is that's where it's app initiated SSO. It doesn't work for the use case of what if you want Okta initiated SSO, where you want to click on an application tile, go into the app then is by, it's being forwarded the IDP info, but then Cognito doesn't support that use case.
Yeah, some of the
it gets really funky.
Yeah,
authorization flows are hard.
Yeah, authorization is one of the hardest things. Yeah.
Yeah.
I understand it to a point, like the federated needing to be requested from the provider, but how Cognito could read the cookie. So the cookie could only be provided from the site that's requested it,
right?
That created it. So, are you saying that the app requests the Okta token, and
so
then that's how Cognito knows?
So what happens is the user says perform an action on the site. The site goes into API Gateway via the REST API. API Gateway is configured because API Gateway has native integration with Cognito, obviously. So API Gateway, you can set the authorizer to say, hey, go to this Cognito pool. The Cognito pool then is configured to point at Okta, a specific Okta application.
Okay.
And then if that Okta application is assigned to the user via group membership, whatever, then Okta responds to Cognito and says, yes, you're good, or no, you're not. And then Cognito responds to API Gateway, yes, you're good to go through and move in. So it's
so it's back end, not browser. Okay.
Well, you're actually making me wonder now. How does Cognito know who you are if I'm not sending it to you via API Gateway? You're making me wonder that, and I don't know now that I think about it.
Yeah, the gotcha always for me is what site created the cookie? Because when you do like a login as Google or login as Facebook, the reason why you have those buttons is because it isn't until that page makes a request to Facebook that Facebook can read its cookie and then return out of that request, yes, you're good, or that user's token that can be passed into Cognito essentially.
Yeah. So I've actually tested this somewhat recently because I was looking at trying to do SAML integration, and I was able to take a URL of Cognito's, not the integration with API Gateway, but a URL of Cognito's, and I was able to hit enter on it. It went into Cognito and it validated who I was, and it even imported the user into the user pool and created the user, all with just a curl call effectively. No cookie required. So I'm not exactly sure how Cognito is figuring out it's me unless Cognito has access to my cookie. That's when
that doesn't make sense, but yeah, like you said, it doesn't make sense.
No, it doesn't. No, but it makes me wonder though, how would API Gateway support Cognito integration for an IDP?
Right.
Unless we can customize sending a cookie into API Gateway.
Right.
Does Cognito support JWT?
Yes.
Yes.
So could it be using JWT, or did you?
Well, it has
you need to control headers at that point though.
Yeah.
Because you would need to pass a header to API Gateway. API Gateway passes that header to Cognito, and then Cognito does something with it. That would make sense. But I was doing a curl call, and I didn't even need that. And that's the part.
Yeah. So the URL, did that have encoding in it?
It had things like the scope you were requesting and things like that. So you could argue that it was kind of JWT-ish, but I think it was more of it redirected the browser. So now this is where the UI gets into play, right? It redirected the browser to Okta. It said, oh, you have access. And then the browser came back to Cognito and it gave it success. And then it said, okay, you can execute and you're now part of the user pool. The question is how does that work if you're integrated at an API gateway perspective comparatively?
Right.
Because now that's not dealing with a UI anymore.
Right. You're no longer in the browser.
Right.
And so you have no cookies.
Because I do know with Cognito, when you get redirected back, it puts in an access ID or token or whatever in the URL.
That's the token that it got back.
But that's the token that you then use with your actual REST API call, which, because that token now maps. So it's almost like you need a login button or something, some
login
event.
as button.
Yep. Yeah. I don't know.
Yeah.
It makes me want to go and test it a little more.
Yeah. It's I have so many things I want to go and test.
Yeah.
The list is too long.
Yeah.
Well, guys, if there aren't any more questions.
A quick question, Cognito,
Right ahead.
does it support like API authorization? Like, I guess, like, say if you want to only have someone that's logged in make a post request, can Cognito support that?
Yes. Yep.
Okay.
So that Cognito is the authorization piece. It stores passwords or links to external identities like Google and Facebook. And so that is the piece that says you are logged in or not logged in. And it also has role stuff in it. I tend, like, when we are using Cognito, I tend to just use it for am I logged in or am I not logged in? And I push everything else into the application. I do role handling outside of Cognito because if I was using Okta, that role handling is a little bit easier to manage. Cognito can be a little bit tricky, a little hard to work with sometimes, but it's great if you're just, as long as you're just doing the user authentication. Is this person properly logged in? Yes, no, then it's great. And then it has an identifier in the header, so then you know that user ID when you're in your Lambda. And I have I store that in a database somewhere and attach whatever other attributes to that ID that Cognito passes. So when a user is created, I create a kind of a parallel user. I just capture the ID in a database table and attach roles or whatever other properties I want to attach to the user in the database.
Awesome. Yeah. Thanks.
Cool. Anything else? No? All right. Well, thank you, everybody.
Yeah. Thank you, Josh.
It's been fun.
Yeah, great presentation.
Thank you.
You're very welcome. Have a good night, and don't forget, next week, Tuesday, we'll get together and talk about what we want to do next month.
Cool. Bye, everyone.
Thank you.
All right.